Hello, good afternoon, everybody. Thanks for joining us for this webinar from the BIMFoRen project entitled Tools for Data-Driven Renovation Design. So today we have a 1.5 hour agenda. We will start with the coordinator of the project, Antoine Dugue, and he will introduce the BIMFoRen project and the data-driven design approach. Then we will follow with 3 panels. The first panel will be called Evaluating Renovation Scenarios. And there we will have 3 short pitches of the 3B tool, the Renovation Manager, and the scenario comparison, followed by a brief 15-minute Q&A. The next panel we will have is called Zooming In on Renewables and Life Cycle Performance. The 3 tools presented in this panel will be BIMSolar, HeatPuRe, and BBest, followed by a Q&A, as of course. And then the final panel will be called Collecting Post-Renovation Occupant Feedback. And the 3 tools for this panel will be the Feedback tool, React, and SMACH. So I will now hand it over to Antoine Dugue, the project coordinator, to introduce the project.
So, thanks a lot, Dia. Good afternoon, everyone. We are here presenting some outputs of the EU-funded project called BIMFoRen, which is about the use of BIM for the renovation of existing multifamily residential building. And the idea of this project is to develop easy-to-use tools to put them in the hands of the practitioners of the renovation of the building stock in Europe. So we are a project across 4 years that started 3 years ago and involving 23 partners from associations, universities, RTOs, companies across Europe. Next one. And so the topic is starts with the fact that the buildings, existing buildings, are responsible for 40% of the total energy consumption and 38% of the greenhouse gas emissions. So there is a need to for the renovation of these existing building stock, and at the current rate of renovation is too low. It needs to triple actually to meet the objectives set at the EU level. And on the other side, the construction sector is a sector with very low productivity. It has also very low use of digital tools. What we can also add to the specificities of this construction sector, it is made of small companies. Even though we think about the majors, the vast majority of buildings of the companies in the construction sector are SMEs with less than 10 people, and they manage to carry out most of the economic activity of this sector. So there is a need for a digital transformation to put in the hands of those small and medium companies the tools that will facilitate the energy and environmental renovation of existing buildings. And so we deal here with BIM, which is maybe more usually, or at least perceived, used for maybe new buildings. And the BIM as building is a building information model or modeling, is both a collaborative process in which it's all partners involved in the projects work together for the generation and management of a digital representation of a building. And on the other hand, it's also a standard format to describe semantically a model of a building covering its full life cycle. So BIM, on those 2 different considerations, can be used for a more efficient, more collective way of doing the design, either for new buildings, but also for existing buildings for their renovation amongst all stakeholders involved in the project. So it has a huge potential, BIM, to both allow to increase this renovation rates and involve those small companies that are somehow left behind in this digital revolution. And so this BIM for Rent project, starting with those considerations, wants to deliver 4 innovation pillars. One is about the workflows themselves. What needs to be done is to consider the current practices, the needs, and deliver adapted digital-driven workflow to better integrate those tools and for those practitioners. On the other hand, those workflows will be developed in an environment which is relying on state-of-the-art, meaning high level of open and decentralized environments for the BIM solutions to be developed, which allow data collection, data management, and data-driven design. And so those 2 pillars that allow the development, we have a set of tools that are developed, and then they are integrated in this 3rd pillar, which is the one-stop access platform, where all those services are integrated all together for a single entry point. It's not so much a full integration rather than a single entry point to access for a user to access to different services, either fully integrated or external services through different guidelines. And last but not least, the pilot as living labs is the idea, the concept of using, in our case, 3 different locations, 3 different use cases of stakeholders and buildings for which we consider the full renovation of those buildings, for which we consider current practices, but also the opportunity to test the developed tools. Next one. And so the concept starts with the idea that for a renovation project, there is an existing building. So we are not starting from scratch. We are starting with an existing building for which we need to collect existing data. We need to characterize the building as it is. And when we say building, it's about its intrinsic characteristics, when it was built, what's the local regulation about, what's its current energy performance, potential degradations, what are the occupants, but also what is about the renovation project, what are the end goals, what they want to achieve with this renovation, either for the occupants, for the building owners, and so on. What local regulation we need to buy to. And then once we collect this information, we need to manage that. So we need to store it by creating a BIM model. Then we need to organize, consolidate, to secure this information, to make it possible to exploit it in this BIM model for other services. And those services, in our case, are to help in the design of the different renovation scenarios, different renovation options. We focus mainly on the energy and environmental aspects, also taking into account the cost of funding. And the idea is to base it on data-driven, meaning the possibility to produce data and exploit the data to help in the decision making. And those 3 steps are next integrated in this overall access platform. And the very last step I just showed, which is the data-driven design, will be the focus of today's webinars. And my colleague from IES, Giulia Barbano, will be introducing this 3rd step of the workflow.
Yes, thank you, Antoine. And indeed, just to give a little bit of more detail on this data-driven design in BIM4N, our objectives in the project were to create a stack of tools that would be used to guide the renovation design from the early concept all the way through to detailed design. They need to take into account multiple sustainability criteria. So as Antoine mentioned, just energy, but sustainability overall. And they need to address multiple user stories. So we needed to foresee different levels of complexity for each tool or across the stack to make sure that we could have both experts and non-expert users because of the variety of the potential end users involved. So then from these complexity of renovation needs for all these diverse contexts and the use cases we've also collected through the living labs, the different workshops, different data availability we had, we developed this wide variety of solutions. And they've also been developed so that they can have a broad applicability in different contexts. Again, referring back to our living lab context, and they can serve those needs of many end users. Finally, the idea then is that to serve those needs of such a diverse value chain, the users can mix and match to fit the tools in the stack to the needs of a specific renovation project. And this is what we're currently doing right now, testing these in the living labs to demonstrate their broad applicability. So in general, the process that BIM for Rent covers, the renovation process that's covered, goes all the way from strategic planning through gathering data offsite and on-site, doing a diagnosis of understanding what is the situation in the building, and then getting to the conceptual design point. In terms of the tool stack that we've developed, we have, at a high level, we have developed some tools for scenario evaluation, which kind of somewhat map to that those first two, strategic planning and data gathering phases. For modeling and design, so getting in the more detailed analysis, so where on-site visits can be helpful to do those analysis. For the diagnosis phase, it's where focus analysis come in, so specific studies on potential for some technologies and so on. And then optimization decision making comes in for the conceptual design stage. And indeed, because of from the findings from the stakeholders and the end users, we actually have a need for a final step on the occupant analysis and feedback to actually close that loop on how the design was done in the first place. And today we will be focusing on a few of these tools in the stack, which is a rather large of over 30 tools. So we're just going to hone in on 9 of them, on the scenario evaluation, the focus analysis, and the occupant analysis, occupant feedback part. And before we go on to the presentations of the tools, you have received together or after the invite to the webinar a link to the tool demos on YouTube. For each of the tools we'll be going over today, it will be a quick presentation, a quick pitch. There is a more in-depth demo of the roughly like 5 to 10 minutes demonstrations for each of them on our YouTube channel. So if you have not yet caught these, I strongly encourage you to go and check these out if you want to go more in depth of one of the tools that piques your interest today. And I think with that, we can go on, and I will hand back the moderation to Zia to guide us through the demos.
Thanks, Giulia. So to let's see here, the round one pitches, is that it? We're going to the different tools. So Natalia from TECNALIA will start it off, and I'll let the other speakers introduce themselves. Natalia?
Okay, thank you very much, Sia. Yes, good afternoon, everybody. I'm Natalia Lasarte, and I work for TECNALIA, a research and development center in Spain. And I am here to shortly introduce you to 3D tool developed by TECNALIA. Well, the name of 3B tool comes from building benchmark and best practices in renovation. Well, what does 3B tool do? Yeah. Firstly, as inputs, the user provides features of the actual building, such as country, construction year, type of building, systems, etc. And then the building is compared with a reference building of similar conditions. 3B tool estimates preliminarily the energy demand and primary energy consumption of an existing building, based always on pre-simulated reference models. Then it classifies the energy performance grade as good, moderate, or low, considering the energy rating boundaries for each country. Finally, according to the current energy performance and the desired degree of renovation, which can be light, moderate, or deep, it provides suggestions for renovation packages. Please, next. Who is 3B tool for and when might be used? 3B tool is addressed to the general public, even those end users not familiar with energy or construction matters. This is because it is very easy to use and the results may be easily interpreted. It is especially recommended for building owners who manage several buildings and want to assess different alternatives for renovation in a quick and simple way, such as public administrations. It is aimed to the early stage of the project, supporting the decision-making process for selecting the best renovation scenarios. On the bottom of the slides, there are some screenshots of the tool where you can see how user-friendly and intuitive 3B tool is. Next, please. Yes. Why should 3B tool be used? Well, in summary, 3B tool is a user-friendly tool accessible on the internet, which can help you to easily assess the energy performance of your building and also to provide you best practices for renovation. Moreover, 3B tool leverages the engagement of end user to improve their building energy performance by supporting them in the decision making. Finally, the results are backed up with reliable data sources from European regulation and building stock observatory, and therefore they are replicable enough in all Europe. So this has been a quick approach about 3B tool, but anyway, if you want to know further, I encourage you to watch the full demo in the YouTube channel. And of course, I'm happy to answer your question at the end of this block of presentation, and thank you for your attention. And I leave with Sia again. Yes.
So I will be the one presenting.
With Antoine.
So Antoine Dugue here with presenting a tool that has been developed by NOBATEK in EKODENGE. So this tool, which is a bit follow-up from of the 3B tool that has just been presented by Natalia. So with a bit more in-depth analysis, but still with the idea of presenting, let's say, intuitive results at the early stage for building owners or joint ownerships of multifamily residential buildings, and with the idea of doing some kind of web assistant, meaning a tool which is accessible to all, which is easy to use. So who would be the users? It's either a building manager when it's managed by a social housing organization, or it can be involved with potentially more technical guys, let's say, such as engineers that are involved in the assessment of the potential renovation of such buildings. The idea of this tool is to, at the early stage, to participate in the collection of existing data to manage and store information on this building, but also to start collecting the renovation objectives either from the building owner or potentially from occupants. Then it allows to assist in the work planning with a Gantt chart feature, and then by defining the existing state of the building and considering potential modifications by accessing BIM objects catalog for windows, walls, elements, and so on, it allows to define a wide range of renovation scenarios that are evaluated, that are assessed, considering criteria such as energy consumption, comfort, CO2 emissions, and the cost of the renovation. And the final objective, which is quite paramount in this case, is the idea that the user can explore the results dynamically and to identify the best solutions. So if we can go to the next one. So on the left, what you can see is what are our outputs, what are the criteria that we wanted to integrate to have a quite, let's say, global, holistic view. That we consider the summer comfort, we consider the cost, we consider the equivalent CO2 emission of this renovation, and the energy consumption for heating, cooling, ventilation, lighting, and well, I guess there are some button that will some animation, but doesn't matter. The overall process, if you just, yeah, that's 4 boxes. The idea is to have to add a building, and for this building to initiate a global renovation project, then to focus on the energy, environmental performance by considering different modifications. Those modifications, you can see those on the right. The building is composed as envelope system, walls, windows, roof, floor, doors, and even the infiltration, but also the HVAC systems for the ventilation, the heating, the domestic hot water, the lighting, while the usage, the occupancy is fixed, it's not modified. And it allows to define up to 8,000 scenarios of the renovation and to generate that. So on the last slide, you will see a step-by-step, can go next, on the step-by-step use as a use case. So you need to describe first to create a project on this web tool, which is very easy to use with an account to describe the renovation project and renovation alternatives, to collect existing documents such as that will allow to describe the existing state, to load energy model and the weather file, and then by considering amongst the potential alternatives of modification of the walls, of the windows, and so on, to select and define all potential renovation scenarios that will be computed, let's say, on the cloud. And from there, to collect few minutes or few hours after, depending on the number of simulation, to collect and visualize the performance with, again, the energy consumption per types of, again, heating, domestic hot water, lighting, ventilation, the carbon footprint, the summer comfort, and the cost. And the idea is it's even dynamic to interact with those results. And so, yeah, more information can be seen on the website or the YouTube channel. Thanks for that.
I'll take over from here. Thank you, Antoine. And I will briefly present the scenario comparison tool that IS has developed in BIM for Ren. Now, the idea for the scenario comparison tool is that the user can start from an existing model of the area and choose a predefined set of renovation interventions to test in a building. Then they can run fast energy simulation and visualize and compare the before and after results. This is part of the ISIM online platform by IES, which is a community resource monitoring and management platform. It can be deployed in communities of any scale, and it can be used to display and interact with these 3D models of the buildings in the community. The idea is that the scenario comparison tool could be used at the beginning of the renovation process, so before the detailed design starts, to choose between the renovation strategies that are more promising. The tool already uses actual buildings in their context. Okay, so it already uses the geometries that can be imported from OpenStreetMaps, for example, and the user can add the basic configuration, create a baseline, and add renovation interventions, and run cloud simulations for the building. Now then, the results can be compared, and this is an example that you can see also more in detail in the YouTube video. But here we see how, for example, like in scenario 1, the intervention that we were testing was a replacement of the boiler with a heat pump, and scenario 2, also adding passive interventions. Okay, so from this, the user would get understanding of how the envelope was already pretty good. So maybe it was not the best, it's not the best thing to invest on, the most cost-effective investment to do while the heating source is. And also if the user is really driven by CO2 emissions, then this kind of scenarios are probably not the right ones to pursue. So basically the idea is that this functionality can allow the user to quickly try and add interventions to the building, see what changes, and help at this very early stage identify some viable solutions and explore that can be explored further in a more detailed design. This way, building owners and building managers can quickly make some informed decarbonization decisions before they go and invest in their building and their community. And I'm the last one here, and I think we can go into Q&A.
Okay, thanks, Giulia. So the first question is for Natalia about the 3B tool. Natalia, what are the inputs needed for the tool? Okay, it looks like we're missing.
Yes,
There she is.
sorry. Yeah, now it's okay. As I said before, this is a user-friendly tool accessible to the general public without a specific knowledge about that. Then the user must select some data about his building, very easy to find out. These data are basically the country, the year of construction, the last building's upgrade, and building typology, all this one for estimate the energy demand. But if you want to estimate the energy consumption, the end user must select the heating and cooling system existing in the building, and also the share of renewables. Yes, and with all this information, very easy to find and very accessible for a non-expert user, the energy consumption can be calculated. Yes, I don't know if it is enough or
Yeah, thank you. And how accurate is the tool in your opinion?
Yeah, so let's say that we can say that the tool is quite accurate because it relies on parametric dynamic simulation, or yes, that's even more than 500 scenarios, I think, have been simulated. So it means that the approach or the methodology is based on real simulation, and the information for that is taken from European building stock and observatory and the national rates for energy performance certificates. So it is quite reliable for because the data sources are reliable. However, as it is a tool thought for non-expert, the data have been simplified, and the information is very straightforward and easy to know. So because of that, there is a relative incertitude in the results because of this simplification of the inputs. This is the reason why this tool is addressed to the early stage of the project to support in the decision making to end users by comparing different scenarios. It is a very quick and simple way instead of a very accurate calculation for the design files that can limit the access to the tool to the general public, let's say. Yeah, I think it is clear.
Good. Thank you very much. So keeping with the same order of the presentation, Antoine, about the renovation manager. What can you talk a bit about, for maybe 1 minute, about cost assessment, how this would be based, please?
The cost assessment, we are using open database of the individual cost for the types of modification I presented, again, windows, walls. And so out of these database, we consider through, let's say, IA-based algorithm, the way to extrapolate on the most specific chosen renovation. So for example, for a domestic hot water tank, out of the database, considering different kind of water tanks, we will generate the cost for the selected water tank in the renovation scenario.
Great, thank you. Excuse me. And the final question for you, Antoine, is what would the computation time be to run around 1,000 simulations?
Well, yeah, one of the major idea is to be able to run a lot of simulation by considering different combination. Obviously, we can generate lots of simulation, and so it's quite a potential barrier, let's say, to face high calculation time. And so in our case, depending on the size of the, let's say, the basic energy model, if it's a bigger building or a smaller building, let's say, it's in between 20 seconds to 2-3 minutes for one simulation. So you can multiply that by 1,000. So you can actually go up to a few hours. But we have been working on using, let's say, machine learning based algorithm to reduce the computational time, and we managed to divide it by 4 while getting the same accuracy on the results.
Great, thank you. And then for the final questions to Giulia, thanks, Antoine. So Giulia, about the scenario comparison, what level of detail can be analyzed using this tool, please?
So it really depends on the starting model here. It could be as simple as starting from a box, just from the shape that's in the OpenStreetMap available for the location, but potentially the geometry could be made more complex. It will get to the level of floors, so it doesn't go all the way to rooms, for example. But if there are multiple floors, then that's the level we'll get information at. And then again, depends on how much information you have in your building. So it really lets you go in and customize, add some information from a predefined set also of templates to say what is, for example, the existing heating system, what is the existing glass pane, and so on. So it kind of helps doing that initial data gathering at the beginning and starting get that initial information that can be refined further in other analysis.
Great, thank you. So that will conclude this first panel, unless there's anything you all would like to add. And next we will move on to the second of the three panels today, entitled Zooming in on Renewables and Life Cycle Performance. So the three tools that will be presented briefly will be BIMSolar, HeatPuRe, and BBest. And then at around 3:45, we'll have a 15-minute question and answer. So please, everyone, feel free to put your questions in the chat and we will address them after these brief pitches. Thanks. So Philippe, the floor.
Good afternoon, everybody. I'm Philippe Alamy from ENERBIM, Associate Director and founder of the BIMSolar program. To urban planners, architects, and energy consultants, we need to get crucial KPIs to support their decision to go solar, as energy prices are dramatically increasing. The BIMSolar platform offers a unique BIM-based service, solving PV thermal feasibility studies and generating the next generation of ready-for-service BIM objects, the first BIMSolar objects. What is BIMSolar? BIMSolar is first a desktop software but also a solar design tool addressing photovoltaic and thermal solar systems, a BIM solution with pure solar objects, a web platform under expansion with web services. The main features are the importation facility of OpenBIM geometry, IFC, for example. Also, building energy modeling, geometry importer, IDF format, and GBXML format. And we developed also Revit plugins to enable the creation and replication of solar objects families. Eventually, BEA-PV, BI-PV, PV, and thermal simulation with hybrid objects are enabled. The technical outcomes from BIMSolar are the following: PV plus thermal generation, electrical production, of course, also waterfall of losses, and of course, self-consumption scenarios, which is the main objective today. The BIM4N typical results for this project are the integration of PV plus thermal models into BIMSolar. Also, the development of the related PV plus T BIM objects, as you can see on the picture, the refinement of the user interfaces and the user experience still ongoing, and the involvement into the decision support chain, the early decision support chain promoting solar renewables in the decision to go renovating. Thank you very much.
Bruno, you're on mute. Sorry.
Hear me now?
Yes, good. Thank you.
Okay, so perfect. So my name is Bruno Bampi. I'm a researcher in Fraunhofer Institute for Solar Energy System in Freiburg, Germany, and I'll be presenting the HeatPuRe tool. So HeatPuRe stands for Heat Pump Retrofit Potential. The tool addresses anyone willing to implement a heat pump in an existing building. The user does not need any specific know-how on heat pumps to use the HeatPuRe tool, but it's important that the user has some know-how on building heating systems and also building heating demand, as some of the inputs are, for example, the heat load of the building during a whole year, and also information about what type of heating system there is in the building. For example, if there's a radiator or if there is a floor heating, and also some inputs are price signals and also specific emissions for different technologies. Please move on. So what HeatPuRe does, it will get all this information about the heat demand of the building and also this price and CO2 equivalent emission signals, and will simulate the performance of the system shown on the right side on the slide. So this system is a typical heat pump system, which consists of a heat pump plus an auxiliary heater and two different storage tanks, one storage to cover the space heating and one storage to cover the domestic hot water demand. And HeatPuRe will simulate the system to cover the heat demand and also varying some types of the source used for the heat pump. For example, it could be an air source, so an air heat pump, or a brine heat pump, which will use geothermal energy source, and also would vary the type of the auxiliary heater, because it could be a gas boiler, for example, or a electrical heater. Please move on. So in the end, what the user will have is all this information about the possible combinations of this heat pump system, and we'll have the information about the annual energy cost that the system will have, and also the annual CO2 equivalent emissions. And this will help the user to really take decisions of what type of system he would like to implement or not on the building, which he wants to actually change his heating system to a heat pump system. And also a very important outcome of the HeatPuRe tool is that we'll size all these components. So in the end, the user will have all the rated power of the heat pump, of the auxiliary heater, and also the volume of the tank storage. So this will help the user to really choose the type of system he will implement on its building. That was a short introduction to HeatPuRe, and I'll pass on to Rembrandt, who will introduce the BBES tool.
Thank you kindly, Bruno. So the BBES tool, we're moving from heat pumps. We are moving now to another area of improving the sustainability of buildings, but this is looking more at the design phase from a renovation perspective. So it's we are in the phase of evaluating the renovation itself and looking at two aspects in the building environmental sustainability tracker. One is the aspect of the environmental analysis, so specifically on embodied carbon in the supply chain. So what kind of materials selection has an impact on the carbon emissions associated with the building renovation on the top. And the second aspect in the tool is to look at the life cycle costing. So it calculates the financial aspects related to energy savings of the renovation and building value increases with the costs of the renovation. Next slide, please. So on the life cycle assessment, we have a rapid tool that allows you to enter the information of your renovation and upload your digital building file, your IFC file, to parse it into the components in your building. And what we can then do is to enrich that information with the materials data if it's not already in the IFC file. Sometimes it isn't there, sometimes it isn't in there. So we can enter additional information manually and generate a bill of materials, which can then be downloaded in a spreadsheet format, also viewed online. And we match that with lifecycle databases. So databases that contain information on, say, if it's a wooden panel, or if it's a that's being replaced, or a plasterboard, that material board that's included in the renovation. We obtain the information on the supply chain requirements, the energy material requirements, and calculate the carbon emissions and other indicators. And that then gives you a renovation dashboard. Then the second part of the module is the life cycle costing. So here what we can do is to look at the renovation details. What type of renovation is it? In terms of, for example, in this example, an energy retrofit. What's the lifespan in terms of financial lifetime? Default lifetime would be 10 years, but it could be longer. This relates to the timing of, say, if there's a loan of the renovation. What's the duration of the loan? We enter cost information. This is also a library with some standard cost information from the countries involved in the project per square meter. So, and also the energy savings information. So what do we have? 30% savings from before and after, and associated with the price. And also looking at the building value increase in square meters. And we then calculate, we get outside and on the right, you see the type of results. We get a payback time of the renovation in years, net present value in euros, and we can directly also graphically compare the investment costs based on different cost components with the savings in energy over that 10-year period or 15-year period or 25-year period as deemed of relevance, to give a perspective of, is it financially worth to renovate, and if so, what's the total financial revenues across that period of time. That's a very quick summary, but thank you very much.
Great, thank you all very much. So the first question will be for Philippe. Philippe, can you please talk a bit about the cost of BIMSolar, if it's free, and if not, how much it costs, please?
Today, BIMSolar is free because it's a beta version before going commercial, but at the end of this year, it will be around 500 euros per subscription, yearly subscription.
Okay, thanks. And what type of 3D formats can be imported into BIMSolar?
So you can import native formats like SketchUp and Revit through a plugin. And you can also import OpenBIM format like IFC and IDF and GBXML energy modeling formats today. And we expect also to enable importation of FBX format.
Wonderful, thanks. The last question for you, Philippe, is does BIMSolar provide feasibility studies for solar systems?
Yeah, this is the main ambition for BIMSolar, to provide very early but strong and accurate feasibility studies support through the combination of technical studies and financial analysis, of course, to provide the best KPIs and the best variants in terms of energy production against cost simulation. And LCO analysis, of course, for electricity.
Great, thank you, Philippe. Moving on to Bruno about the HeatPuRe tool. Bruno, how is a heat pump described in the tool? Is it possible to consider specific characteristics provided from specific heat pump providers or maybe through BIM objects?
Very good question. No, it's we'll have by many empirical data, so many heat pump data that was tested in Fraunhofer. We have parameterized some characteristics of the heat pump of two different heat pumps, so an air source or a brine source heat pump, and we use this characteristic heat pump. So the answer would be no, you cannot really input a characteristic curve of a specific heat pump.
And is there any plans in the future to cover additional types of heat pumps? Perhaps
no,
air.
No, at the moment we don't have like there's not intention so far of opening that the user could actually upload a characteristic, let's say COP heat pump, depending on the heat source and temperature side and the sink heat temperature side.
Okay, thank you, Bruno. So for a given building, can we compare scenarios where we renovate an existing gas boiler against a scenario where we install a new heat pump, for example?
Before and after renovation, yes, but then it's it will be two different simulations, which then it changed the heat demand of the building. So you have a heat demand before renovation and after renovation, so you would have to do two different simulations, right? You will have to input first the heat demand on before renovation and then do a simulation after renovation and maybe compare them.
Okay, thank you. And Bruno, the last question for you. I know Rembrandt discussed life cycle cost, but for HeatPuRe, how can someone calculate the life cycle cost?
Well, then we will have the user would have to do it, because the output of HeatPuRe is only the annual energy costs. So, for example, for a complete life cycle analysis, you would have to input a lot of other costs. So, for example, investment costs, and so on. So, like with HeatPuRe, you could get the annual energy costs, but then the other cost analysis would be the responsibility of the user, I would say.
Okay, great. Thank you very much, Bruno. Moving on to Rembrandt. Rembrandt, for the Be Best tool, what situations would be useful in your opinion?
Yes, so I think what I already mentioned this briefly, but the tool is really intended for kind of decision making on how can we improve the kind of renovation scenarios. So we're planning a renovation, but maybe there are different considerations on carbon in the procurement, if it's to analyze this. So if you need to have any embodied carbon information or trying to see, okay, can we improve that? And the second one is the kind of questions which you had already mentioned, I think, Bruno, if, okay, we need to have a more detailed cost assessment that looks at, for example, an ESCO type contracting scenario, or depending on the financing of the renovation, where it's possible to claw back some of the savings over time from the energy savings, and to have a rapid estimate of that based on, we can enter the values for the energy savings, and we can look at the costs, and then we can see, okay, what if the cost per floor space, say on materials, is 15% more expensive or 15% less expensive, or on labor, and so we can look at different parameters and play around with them and see in what cases then an ESCO type model would make sense. So I think those are the type of scenarios that could be useful for using the tool.
Great, thank you. And what type of insights can be gained from a combined environmental and economic assessment?
So since we have both the modules, you can, we don't have that in the current version, but in a further development, we can plot against, we can make scenarios, and then we can plot which scenarios have win-win situations potentially. For example, in the material, especially the material selection. So if we choose a different set of material items, shifting from, say, less mortar and brick to more wooden-based structures, does that deliver more cost savings or more cost increases, and what does that mean for your environmental impacts? So I think that those are the type of trade-offs, especially to look at carbon versus renovation costs. And of course, that also then has energy implications potentially, if the installation values. So that could then be a third dimension that you could look at. Does it deliver more or less energy savings if we say include more insulation padding material into our, is it 2 millimeters or is it 8 millimeters? So you can start to look at those type of comparisons too.
Great. And the final question for you, Rembrandt, is what if I don't have specific cost information available yet for my renovation? How could the BBEST address this hurdle?
Yes, so we started with, we have a base database for 3 countries, but it's quite generic, but you can start off with creating scenarios with those estimates for each category. Each of the main categories of materials, labor costs, auxiliary costs, and investments. So we have that, and so that can be used to immediately generate results, even if you have no values available. Of course, if you have specific values available for your renovation, the quality of the outputs will be better. And the intention is over time is to advance this kind of library to make it more regional specific.
Wonderful. Thank you very much to the 3 presenters of the Zooming In on Renewables and Lifecycle Performance panel. And next we'll go to the final panel of the day, entitled Collecting Post-Renovation Occupant Feedback. So we will start with Olav presenting the feedback tool. Olav, the floor is yours.
Thank you. Good afternoon, everyone. The feedback tool is especially for occupants, because we know that the behavior of occupants has a big influence on the energy use of the buildings. Even after renovation, you can see that the same houses with the same isolation level, etc., still have a huge difference in energy use, even up to a factor of 4. So therefore, we developed this feedback tool, and the aim of this tool is to give occupants the insight of what the effect is of their behavior on the amount of energy they require for heating and cooling. And in this specific case, we focus mainly on thermostat settings and the opening and closing of windows and the use of solar shading, because we use the Spanish pilot for this tool. So we collect measurements. We collect measurements about temperature and energy, and we have a questionnaire about the behavior, about how they have their set points during the week and every day, and how to use windows, and how to use the solar shading. These two inputs we combine in a RC model, which we calibrate based on the measurements and the questionnaires, which we use as a kind of pattern. And based on this, we create what we call a digital twin. And the digital twin is actually what we use in the background of the feedback tool. So if you go to the next sheet, then we can see how the feedback tool looks like. So when it is loaded the first time, it will be pre-filled with the settings as the questions has been answered in the questionnaire, and they can be changed. So each value can be changed individually, or for the different times of the day and the different days of the week, for the thermostat, the ventilation, and the solar shading. And you can push a button to run a simulation directly in the background. And if we then go to the next sheet, then we can see what the output will be. So we can see that you can choose the unit of energy, so it's in kilowatts or in cubic meters, but also in financial, like in euros. And you can see what the comparison is between the current behavior and what your behavior could look like if you change it, and what the delta will be. So how much energy you can save, or how much, well, euros can be saved, and also what the effect is on the internal temperature, so on about the comfort. So the idea is that really, like, the occupants can have, based on a calibrated model, they have like the most realistic outcome of the simulation, and so they can see what the effect is of changing their behavior, and see what it directly means in comfort and also in energy or in money for them, which is probably the most interesting part for themselves. Yeah, so many thanks for your attention, and can go to the next presentation.
Thank you, Olav. Next up will be Artūras presenting the React tool.
Hello. React generates and maintains a customized adaptive environment for users, considering the measurement pertinent to their emotional, affective, and physiological states, also valency, arousal, and user performance, as well as happiness, interest, and non-boredom. It is mean different affect states. Also, the React analyze, customize, and manage the quality control pertinent to building smart spaces according above states in an integrated manner. Also, the customized management of quality control covers levels of lighting and colors, intensities, sense, media, information, activities, lighting materials, games, music, videos, temperature, energy efficiency of a building space, humidity, air pollution, vibration, and the like for smart spaces. The system is based on digital twin technology, seen as a logical extension of building information modeling. React has new worldwide attributes comparing to existing solutions held by key companies in the global smart building market, including React upkeep of the best personalized indoor environment quality, boosting productivity, happiness, interest, and non-boredom, energy efficiency upkeep for tackling climate change, establishment and upkeep of needed user emotional and affective states, integrated analysis of user emotional, affective, and physiological states, also by applying neuro decision-making and neuro correlation tables for compiling customized regression models pertinent to controlling microclimates of building facilities, also applications of biometric and intelligent technologies set for various built smart space values, such as user performing, hedonic, utilitarian values, system provision of open depersonalized data, This innovation broad impacts include societal impact. The system principle is improving use and living conditions and indoor air quality, while in turn improving working and living environment in general. Because a poor working and living environment can damage user health and lead to serious illnesses. Next is economic impact. It's increasing user productivity by managing emotional, affective, and physiological states due to added comfort and attractive working or living conditions, which will induce achieving better economic results. Also, wide application is possible due to system implementation possibilities and building information modeling and mobile work sites, and also environment impact, promoting efficiency use of energy according to individual needs. Existing solutions do not include integrated real-time remote identification of different human characteristics. Upkeep, the best personalized indoor environment quality, boosting productivity, happiness, interest, and non-boredom. Energy efficiency, upkeep for tackling climate change. Establishment and upkeeping of needed user emotional and affective states. Integrated analysis of user emotional states. And the application of different technologies for calculation various values. Thank you very much for attention.
Thank you, Artūras. The final presenter today before our last Q&A session will be Mathieu. Mathieu will be presenting the SMACH tool.
Right. Hello, everyone. I'm Mathieu Schumann from EDF Research and Development, the electricity company in France. So I will present the SMACH tool, SMACH meaning simulation of activity and consumption in the home. I can also call it an occupant behavior simulator. So basically, SMACH is a tool that is aimed at energy experts who are involved in the renovation process as a means to engage occupants more in the renovation process in order to promote energy efficient post-renovation behaviors. So basically what SMACH does is that it simulates the behavior and the activity of occupants in their building. And in the end, it allows to assess the specific impact of behavior on the efficiency of a renovation project. So when I say simulation of activity, I mean what people do during their day. So getting up, going to work, preparing the meal, watching TV, etc. And also take into account the choices that people made in terms of indoor comfort, indoor temperature, and also the use of various appliances in order in the end to reconstruct the energy consumption. And when we do a SMACH simulation, we want to define characteristics of the people that we want to simulate, taking, for instance, into account their age, gender, their work occupation, the family composition, etc. Also the different appliances they have, energy tariffs, and the characteristics of the building. And so why do we do this? It's because, as it is established now, behavior strongly impacts the short-term but also long-term success of a renovation project. And in the next slide, okay, go to the next slide, thank you. So thanks to the BIM4N project, we adapted the SMACH simulator in order to take into account characteristics of building based on BIM models and on BIM 3D models in particular, and so that we can perform personalized occupant behavior simulation based on a specific building that is studied through BIM in a renovation project. So we use the geometrical characteristics of the building in order to associate the SMACH parameters to the real building that we are studying. In the last slide, I show one of the outputs of SMACH, which is basically a visualization of what people do during their day. And thanks to this, we can associate this to energy consumption and better understand the impact of behavior. And so SMACH can be used before a renovation project, for instance, to anticipate the role of occupant behavior on energy consumption, but also after a renovation project, so we can advise occupants on the best behavior that should be done to foster and maintain energy efficient behaviors and how to benefit the most from the renovation. Thank you for your attention.
Thank you, Mathieu. So now we'll go to the question and answer portion of this final panel. So the first question is for Olav about the feedback tool. Olav, considering the focus is on occupants, are there any specific competencies required to use this tool? And are building occupants the targeted end user of this tool?
Yeah, so the tool itself to come to, let's say, the digital twin, it's expert knowledge, but the use of the interface is very straightforward, so the occupant can really play around with it. So basically, you need measurement data and the questionnaires to calibrate the model.
Great, thank you. Is there anything else you wanted to say about the feedback tool, Olav? We have a few minutes if you want to add anything.
Well, I'm really interested to see if people really are changing their behavior, because we find that it's really difficult to influence it. And with this tool, we hope that people get more insight and therefore also really change their behavior.
Okay, great, thank you. Moving on to Artūras about the React tool. Artūras, which smart spaces and human parameters are under evaluation across the alternative scenarios?
We analyze different emotional states, for example, happiness, sadness, and other emotions, also affective attitudes such as interest, boredom, as physiological states such as breathing rate, heart rate, and brain waves, and also arousal valentia. And this tool is quite simple, and user should fill in some requirement characteristics, because we have very big differences in cultures. For example, some people are very emotional and are not emotional, but it's a very simple tool in the use, and there are only a few questions for inhabitants or for users.
Okay, thank you. And
for example, if your heart rate is 60 and during a few seconds will rose till 90, it is mean that you have quite big reactions. For example, heart rate, breathing rates, and a lot of physiological parameters shows a lot of giving a lot of information about user.
Great. And which values of the smart spaces are calculated by React? For example, user perceived, utilitarian, hedonic, etc.
Yes, this tool calculates these values according a system of different criteria. For example, comfort level, happiness level, temperature, indoor quality, a lot of criteria with different values and weights, and system calculate various values. For example, some smart spaces are more appropriate for user, and in this case, hedonic value always is increasing, because hedonic values analyze not only technical, economical characteristics, but also different emotional and affective attitudes characteristics. And for example, maybe some investment value is not very high, but if a person feel you have very big happiness or interest in some spaces, in this case, the tonic value is increasing. In this case, our system is different from another systems for calculation of different value because we're including different emotional and affective and physiological values. Is additional value for analyzing of different values in housing or in offices.
Great, thank you. And the final question for you, Artūras, is React involved in using neural decision making and neural correlation tables when compiling all the possible alternatives pertinent to qualitative, customized building smart spaces?
Yes, because we have a lot of, we have currently about 500 millions data, and from this data we have a lot of different correlations. For example, how is possible to improve happiness? For example, how happiness for concrete person depends from humidity, from temperature. Also, we're analyzing diurnal characteristics. For example, Friday is most happy day. Evening, Monday morning is not happy time. And also we're analyzing a lot of different characteristics, and according to different correlations, we can give some formulas how it's possible to increase happiness or productivity. As I said, for example, if you get some information, for example, if you get very happy informations or you listen to very happy music, your mood will become more happy. If you listen sad music, or for example, you get very sad news about war, about COVID, about pandemic, of course your mood is decreasing in a bad direction. In this case, we can analyze a lot of different alternative factors of smart spaces, as I said, including data information, knowledge, temperature, humidity, different colors, intensity of lighting. Also, we're producing different another effects. And according to effects, we can regulate mood of people and increase productivity, for example, or decrease the boredom. There are a lot of different characteristics. As I said, we have about 500 million data for analysis.
Wow, very interesting. Thank you, Artūras. Moving on to Mathieu, the final speaker for the day. About the SMACH tool, what kind of user behavior scenarios can be explored using?
Yeah, right. So in the SMACH tool, so we have a few predefined scenarios as of today, such as classic related to a comfort behavior or more cost-effective behaviors. But as a research tool as well, it's a very flexible virtual platform for testing what-if situation, what-if scenario. So for instance, what if I adapt my behavior based on the energy tariff that I have, because maybe it's not the same cost during the day? Or maybe what if I manage my heating differently because now I work from home due to the current situation, and what is the consequence of this? Or what if I try to be more flexible because in the evening I will try to consume less, for instance. So you can basically define these kind of scenarios yourselves and see the impact. And I think another addition is that I talked a lot about actions, activities of individuals. But in SMACH, we're also very interested in studying the collective behavior and the collective preferences. So if I have a family, we are two people, we also have two children, how do we manage things? How do we act during the day? And what's the impact on our energy consumption? If we change some habits, what is the impact? So basically, it's not necessarily predefined, but there is a lot of flexibility to define the scenarios that you're interested in.
Thank you. And what if I don't have a lot of input data available to me? How does SMACH interact with me in that situation?
All right, so yeah, that's a question that's related. For instance, in BIM4N, we mentioned that we have pilot sites in which we can collect data and, for instance, access real occupants and ask them questions for instance, ask them to apply to questionnaires. And this is used as input data for our work. But in a more general use of the tool, maybe we won't have access to people, either because people are not there, are not available, or we can't get access to them. So in this case, what we do is that we use basically databases of statistical data to define characteristics of families, of homes that correspond to profiles that we are interested in studying. Maybe if we know that in this region where the building is being renovated, we have more of this type of families, or maybe it's more people who are single and don't work from home, etc. And so basically we can tap in statistical data, so public statistical data, to define the characteristics of the people we are simulating.
Great, thank you. And the final question for you, Mathieu, you mentioned that the tool is mainly tailored for energy experts to use, but can non-energy experts also use this tool?
So yeah, as of today, indeed, it's not like a commercial tool with a user-friendly, easy-to-use interface, but we are testing these interfaces, actually testing these interfaces, so that we can use the tool with no knowledge of the internal working of the tool. So basically, we are developing simplified web interfaces to, in a few clicks, define characteristics of occupant behavior simulation. So for instance, saying, I'm interested in this kind of population or that number of buildings, or maybe only people who use electricity for heating. And with a few clicks only, define the characteristics and then launch a simulation. So it's not yet, let's say, available publicly, but we are.
Great. Thank you very much, Mathieu and Olav and Artūras, for this collecting post-renovation occupant feedback panel. So now these were the presentations of the 9 tools of BIM4Ren. These are just 9 of the 30 tools that are all briefed on the website. And now to close out, I will hand it to Giulia to introduce the 3 levels of engagement available to BIM4Ren in the stakeholders community: the followers, the stakeholders, and the early adapters. Giulia?
Yes, thank you, Zia. Just so thank you all, and hoping that you have enjoyed this webinar. We'd like to invite you to join the BIM4Ren stakeholder community. It's a crucial part of the project. It's a way for you to get involved and to be part of the civil society and interact with the partners. So depending as the level of engagement you're willing to put in, there's different levels. There's 3 levels, as Zia was saying. So the first one is the follower. So there's a low level engagement. If you're curious about the activities, you can join as a BIM4Ren follower, so you get information. It doesn't require an active role on your side, but you'll be made aware of events like this and on the latest developments of the tools and so on. So you follow the project on the website and social media. Then if you want to have more active engagement, you can be a stakeholder, and that is not a primary role, but a more active engagement. In this case, you'll be part of the dedicated workshops to help to validate our workflows and our standards, and demonstrations organized in the pilots. You'll get demos and videos for tools and methods developed in the BIM4Ren project. And finally, the biggest level of engagement is to become an early adopter, where you actually use the developments, including the ones we've shown you before, in your own activity. So in this case, you can be involved in the beta testing activities and be invited to dedicated training sessions on the tools and the methodologies of the BIM4Ren project. You'd also get privileged access to all the pilots and living labs activities in France, Italy, and Spain, and you can test firsthand the tools and benefit from this early adoption pathway that's open for you. So with that, I'd say thank you for joining us, and I hope you will want to join our stakeholders community. And don't forget to go and watch the videos on the YouTube channel.
Yes, thank you. We hope everyone enjoyed this webinar today, Tools for Data-Driven Renovation Design. As Giulia said, everyone who is registered has received an email from me, including the links to each of the 9 YouTube videos. They're brief demonstrations, about 3 or 4, maybe 5 or 6 minutes each, depending on the tool. And thank you, Mirbek, for your question. Indeed, all of the video recording will also be published on the project's YouTube page, for which I've put the link in the chat. And so now I will close off, and on behalf of all of our speakers, thank you. Please do feel free to ask us any questions, and have a wonderful afternoon. Take care.